Coming up on StarTalk, we've got a Cosmic Queries edition all about exoplanets. I've got with me one of the world's experts on that subject, Anjali Tripathi. Welcome to StarTalk. We're going to find out where she came from, where she's been, and where she's going in this world of not only exoplanets, but also as a citizen scientist serving 2 presidents. Coming up on StarTalk. This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. Today is another Cosmic Queries, ever popular format that is, on the subject of exoplanets. Chuck.
Yeah.
My co-host, how you feeling, Chuck?
I'm feeling great, man.
Feeling good about the exoplanet?
Exoplanets are always fodder for great thought, because now we know that there are millions and millions of them. They're everywhere.
I don't know if the catalog has quite hit that yet.
We went from 4. They were like, maybe there's 4.
So I know a little bit about exoplanets, but if we're going to really go in with the Cosmic Queries, we're bringing the big guns.
Yeah.
Okay. So we combed the landscape and we found Anjali Tripathi. Anjali, welcome to StarTalk.
Thank you so much. So excited to be here.
Excellent. Excellent. You in your professional life, not only did original work on exoplanets, you were also found yourself, either on purpose or otherwise, at the intersection between science and society.
Absolutely.
So I want to get to that in just a minute. Right now, you're a research associate at NASA's JPL,
Lovely.
which Chuck stands for what?
I believe Judy Paulson lingerie.
That's right.
Judy Paulson's lingerie. It's all the rage. No,
That's usually classified. Why'd you let that one
That
out?
was classified
That-
information.
Yeah. Now the awesome Jet Propulsion Labs.
The Jet Propulsion Labs in Pasadena, California. Yes. And it's not only a branch of NASA, they collaborate and are basically on the campus of Caltech, right?
Yeah.
I am a Caltech employee.
Right,
yeah.
right. So who signs your checks? Is it Caltech?
It is Caltech.
Oh,
Wow.
Okay, there it is. But you
Okay.
still have NASA overlords.
I do.
I'm pretty sure you do. You know who we had on StarTalk just when she just started
Right.
was the director of JPL, Lori Leshin. She and I
Fantastic.
served on a commission to study the future of NASA.
Well,
We were both appointed by President George W. Bush.
nice.
And said she went on to great things. And
And you,
You
Not
got
so
stuck with
much.
me. I'm so sorry. I'm so sorry.
what a shame. Oh,
but you could dig the Lori Leshin episode out of our archives. That was fun.
right.
I wanted to get to her before NASA got to her, because NASA they want to over control the interviews, but she and I go way back.
Right.
So there was an interval where let's just rock and roll this. all right?
Exactly.
Just say what you think what you feel.
Yeah.
Put
Well,
up-
you're not going to be able to do that with Anjali because NASA is still controlling her. Sorry.
I got the NASA handcuffs
Yeah,
on. It's
Okay,
okay.
no, we'll figure something out here. So at JPL, what are your primary concerns?
I like thinking about what can we see from space, right? So what can you see when you look up about exoplanets and other worlds, and also looking down here on Earth and how we can improve life here on it.
People, when they think of space exploration, they don't always think that from space you can see Earth
Right.
as a planet
Exactly.
and monitor what's going on and how we doing. So this seems to be a really important feature of what NASA can deliver the public.
Yeah.
It's something folks always get wrong. You ask them, what's our most studied planet at NASA? And they go, Mars. And you go, wrong. And you think, it's Earth. And nobody realizes that.
Yeah, exactly.
So you still have roots back where you got your PhD?
I do. Yeah, I'm a research associate at the Harvard-Smithsonian Center for Astrophysics.
Okay, all right. So tell me, before we get back into exoplanets, because that's where we got all the questions are based on those.
Yes, they are.
The science and society part of your life, how did that begin?
So being a Valley girl, we had an earthquake in the 90s and I had to move out of my house for a year. And the people who come on TV, for those of you who've had the pleasure of earthquakes, it's a seismologist who comes and tells you what's going to happen. And I thought, scientists can come and tell you what's going to happen next and
Right.
sort of save things? I want to do that. And then I learned that seismology and geophysics and physics are important, but they don't save the world in the same way. And so thinking about how you can find connections between science and sort of...
You know why they don't save the world? Because they only bring the geologists on after
After the earthquake.
After the
Exactly.
earthquake.
Exactly.
Not just before the earthquake, after the earthquake.
It's true.
Okay,
Yeah.
they ain't saving nobody.
It's a
okay?
doggone shame because, when do we really need them? We just got some readings in. That's when we need them.
Whereas with the astronomers, we're like, that eclipse, get ready. It's coming in 6 months.
Okay,
That's
so
true.
total
Before.
predictive powers.
Yeah.
All right, so now what? So, okay, so the urge doesn't make the reality. So what happened?
I mean, I was lucky enough. I went and served in 2 administrations. President Obama brought me in as a White House fellow.
She was lucky.
Wow.
That was just luck.
I was going to say.
That was just luck.
Yeah.
I mean, I don't like to talk about the bribes.
I served in 2 administrations. That's funny. I used to serve at Wendy's. I was Wendy's manager, and I served for
two tours of duty.
2 tours of duty.
Wait, so who was
Thank you for your service.
who was your first president?
Well, I mean, I was born a while ago. Where lady doesn't reveal her age, but of the 2 administrations,
We're going to triangulate on that if you give us enough information.
President Obama.
President Obama.
Oh,
Okay. And so, in what capacity were you serving in
So,
the White House?
I came in serving the U.S. Department of Agriculture, thinking about climate change. You know, it doesn't matter why your soil is dry. You got to
Right.
get things to grow.
That's right.
Is there a relationship between the Department of Agriculture and the Environmental Protection Agency?
I mean, so I was working on food waste, right, which is something that both
deal.
care about, right?
Big deal.
Because,
Yeah.
I mean, you know, your apple that you don't eat
Right.
turns into methane, which is
Methane.
greenhouse gas,
Yes,
right?
without a doubt.
So,
All right. So, but you didn't just. So, how does the Obama administration connect you to agriculture? What is that pathway?
you know, where else would you put an astrophysicist in government?
Wait, what was your title?
I was a White House fellow.
Oh, you didn't say that. Oh, okay.
Right.
A White House fellow. And so you have these science fellows at the White House.
So the White House fellows are actually, I was the only scientist.
Oh, I
Right.
didn't know that.
Yeah,
Okay.
so it's a group there were 16 in my class, right? So one of them is now a congresswoman. We've got all kinds of folks, a lot from the military and business and law. So the idea is you go and you serve a cabinet secretary as a senior advisor.
Because the cabinet reports to the president. So
Right.
this is still a
Correct.
White House thing.
Exactly.
So the Secretary of Agriculture then became.
Yeah,
Exactly,
okay,
right.
Who reports to the president, and you were working with them.
I'm intrigued by the fact that you get a PhD studying exoplanets. So you're thinking about planets, looking at them from afar.
Right.
And then Earth and agriculture becomes Earth that you're thinking about from afar. So what kind of NASA or astronomical insights can you offer the Department of Agriculture?
Well, I mean, I want it to be more down to earth, let's be honest, right?
Mhm.
And the idea is just that, you know, you can see so much more from satellites than you can with a guy.
Walking around with a mule.
Right.
Hey, they offered to send me to estimator school where they said you're going to walk a certain number of paces in a cornfield, pick the second ear of corn you see, and count the diameter and across. And that's how we estimate the crop yields in America. We still, to this day, don't use satellite technology for the government predictions
That's
on
ridiculous.
crop yields.
What? What's this, Green Acres?
That
What-
I was
what?
crazy. That's crazy.
You got Arnold the pig
Exactly.
predicting the weather? Like
Yeah.
what?
Hey man, so how big is your corn? like that's crazy.
It's quantitative. You count, you
Yeah.
know? But I mean, it's one of those things that it's really useful for all the companies that come in because then it's calibrated ground truth, right?
Okay.
All right.
I mean, in a way that makes sense. So now, but isn't it much better to look at, because you can see from space, you can actually see soil conditions, you can see the crop yields themselves. There's
How dry it is.
how
everything?
dry
Yeah,
you
yeah.
can see, there's so much more information you can get from looking down from above. So what's going on with that?
I mean, and so to your question, right, there is tons of NASA data that looks at the soil moisture, it looks at sort of the different vegetation, and that's all publicly available both to the agriculture department and anybody else.
And to the
so,
person pacing cornfields.
Right.
It's
correct.
available to them,
Right.
but maybe they need a job.
Exactly.
The farmer needs a job. I don't know. So I'm intrigued by this. So that was a tour of duty. It went across the administrations.
That's right.
But then you told me offline, you ended up at the Office of Science and Technology Policy,
Nice.
which is the executive branch that oversees the budget for science in the United States.
Wow.
For science, yeah.
For science, right. And so what were you doing there?
What are we doing with that $13.26?
What are you talking about?
You said the budget for science.
Oh, it's a little bit of a,
I was going to say, that's what it's.
there's a lot of science that they apply to the military. And so then you're talking big bucks.
Oh,
Okay, I'm just saying.
There you go.
Like Department of Energy comes under that department.
That's some
okay?
nuclear stuff right there.
There's some nuclear,
Yeah,
totally
some
nuclear
stuff.
Some nuclear stuff going down.
Right on.
Okay, so go.
No, I mean, writing about, hey, what are we investing in? What are the people and the programs? And I figured that we added the word American in front of everything we want to do. So we wanted American health, right? We wanted
Not just health.
American health.
That was smart.
Thank you. Yeah.
I mean, that is brilliant because when you look at Congress, America. You should have made it that instead of American.
You got to spell it right. Apostrophe M-U-R-I-C-A. Merc.
They didn't teach me that one in my spelling classes,
Okay, so that was clever. And so now more people across the aisle can take ownership of it.
Right.
That's right. Yeah. No, I mean, I will say, coming in to a new administration, it's kind of crazy. Your hard drives get wiped. Everything is gone. You're starting fresh a little bit. And lots of opportunity to learn. So whether you wanted me to have that opportunity or not. But I think, we did some good stuff.
But would you have normally been discarded between administrations?
No.
How did you stay on?
So White House Fellows have a 1-year appointment that's fixed. And so started August of 2016 and went to August of 2017.
Oh, you started at the end of the Obama administration.
I did.
Oh, so you crossover.
You were a part of the transition.
I was, yeah.
Okay.
Yeah.
Wow.
Very cool. So at the time, you told me, again, offline, that you knew I was on a Pentagon board at the time. How did you know about that?
Because I go into 5-sided buildings. I can handle that, not just 4-sided ones.
Okay, right on.
How many 5-sided buildings do you know?
I don't know, because I work at the Hexagon. Okay.
I mean,
That's top secret.
That's
why do you think the telescopes have these hexagonal mirrors, right?
Yeah.
So
The mirror segments of JWST are hexagonal.
That's right.
So that's top secret. Nobody knows about except for you.
There you go. That's right.
But
you know where we came up with that idea? At the Hexagon. not the Pentagon.
Okay. What's your most recent published paper? Was it about climate change?
Yeah, we just wrote a paper together about sea level rise and how you can use satellite data to actually do better job of preparing coastal cities for
Excellent.
sea level rise. Yeah.
Only where like most everybody lives.
Every major city is
on a coast.
Is on a body of water.
Right.
And so
lakes, rivers. What can satellites do for you, right?
Okay, but again, it sounds like the seismologist. It's like, here's what to do when the water knocks at your door. Is there preventative advice?
No, so this
in
is
there?
all about how cities can look at, glaciers in Antarctica and, Greenland melting now to prepare for what's happening in the future, right? Rather than waiting for the level to actually rise, that you have some early warning.
Oh, so you can make predictions.
Yeah, exactly.
And anticipate. Got it.
That's amazing.
Got it. And plus, I'm not thinking about Antarctica or Greenland.
Exactly.
When I don't live near them.
Right.
But their water doesn't carry passports, right?
That's right.
That water molecule go wherever it goes.
Yes, exactly.
So let's get back to exoplanets.
Absolutely.
So your work for your PhD was what?
Thinking about how planets form and how they evolve over time.
Oh, formation of exoplanets. Good.
Nice.
So somebody had to make them.
That's right.
They're not just born whole.
No, exactly.
Okay.
Yeah.
So Chuck, you got questions for it.
We have them right here.
Let's do it.
You want to jump right into this?
Let's do it.
All right. I love this first one. This is Monshell Hicks. And Monshell says, "Hi, Dr. Tyson. Hi, Anjali. Planets are evaporating?" That's it. That's all that it says.
I mean, Monshell's got it down. Planets are evaporating,
Right.
right? I mean, we got the Earth, we got exoplanets, right? Because you've got all this gas that we call the atmosphere that's trying to stick to the planet by gravity, but sometimes you got the heat from that star that's enough that it just pulls it off.
Well, we're losing, helium and what's the other thing?
Hydrogen?
Hydrogen and helium on a daily basis.
Hourly, minutes, seconds, yeah.
Wow.
Okay, but not so fast that I should worry about it and make a thing on. But if there's stars that get brighter or more luminous, and they're gas-rich planets. So how about those big Jupiters that are orbiting close to their host star? Are they evaporating?
Yeah, these planets, right, that we call hot Jupiters because they're so close in.
Right.
And especially since they've always got one side and often facing the stars, so the same side's
Because they're
getting
tidally
blasted.
locked.
Exactly.
Like the moon is tidally locked to us.
Right.
If you get close to a massive source of gravity, it's going to lock you and only look at one side, just as we did to the moon. The moon is trying to do that to us. Did you know that?
Just lead us down the wrong path.
It's just
a new path. A new path.
Like a new path. Don't value judge the path.
A new path.
It's just the orbital mechanics of it.
Come on, we're going over here. Come on, why you
I'm just saying.
Let's go.
So the moon is trying to slow us down, so we only show the same things to it. Yeah.
Right.
That's why we throw in leap seconds every now and then to make up for that. But anyhow, so
wait a minute, with the evaporation, just because I'm concerned about Earth, to be honest. what's going to happen first? Well, our atmosphere, which I understand from Neil, is like thinner than the skin of an apple. Okay, it's thinner than the skin of an apple. Will that evaporate before the sun expands and kills us all? Or what's going to happen first?
All right, Chuck. Don't worry about it. Don't worry about it. There's a lot of things that I'll scare you with. This isn't one of them,
Okay.
right? So the idea is that you will have this atmospheric escape is what they call it, because your atmosphere is literally escaping the planet, happening more and more in the future as the sun gets brighter, but it's not all going to go away before then. So you're safe.
Okay, so
You're good. But again,
We'll
if
be
you were...
crawling around the surface of the Earth trying to breathe.
right, stay low, like you're in a fire. Stop, drop, and roll, just so you can breathe.
Well, I think you're going to want to, go up towards the poles or something like that. The equator's not going to look so hot.
Oh,
Or maybe it is going to look so hot.
yeah, that's the problem.
Okay. Well, you already got this planned out. You moved to join a Santa Claus. All right, what else you got, Chuck?
All right, here, this is TJ Show, who says, "Hi, TJ here from Winnipeg, Canada, eh?"
He does not have that in there.
No, they don't. Okay. They do not.
Okay.
Okay. It says, thanks for taking my question. Hello, Dr. Tyson, Dr. Tripathi, and Lord Nice, longtime listener, and new Patreon here. My question is about intelligent life. If there are roughly 10 million unique organisms on Earth, 99% of all species that have ever existed are extinct, and we are only the only intelligent species out of all of that. Questionable. Let me say, questionable.
Big assumption. Yeah,
Big
go ahead.
assumption. Then doesn't that mean that the likelihood of there being intelligent life on a newly discovered habitable world is about 1 in a billion?
Oh, I like that.
Okay, so there
He's
you go.
fast back of the envelope math.
Back of
there.
the envelope math there.
Yeah.
So he says, yeah. So, and then he goes on, our galaxy might be teeming with life, but intelligent life could be extremely rare.
So let me recast that in another way. So
Go
if you have here's Earth. There's this one branch of vertebrates coming out of fish
Right.
that became great apes.
Right.
Okay. I know some apes, but not all of them were great.
Well, no,
So-
some of them were just not so great.
So, and one thin branch of that are the humans. Anything could have stopped that.
Right.
The asteroid not taking out the dinosaurs would have disrupted the mammals from ever even, quote, ascending to where we are. Just sheer luck.
Exactly.
Okay? Bad luck and dinosaur good luck. So, if this is just one branch out of the tens of millions of life forms, if you have tens of millions of Earths, close your eyes and throw a dart. Really? Most of them will just have life like we got here.
Just life, but it
Just
will
life.
not be developed.
So react to that,
intelligent
please.
life.
I'm just saying I'm not smart enough to know what else is out there in the universe, and certainly not the numbers of that. So I think, if we're being honest, do we know if there's life out there? I don't know. Do I hope there's life out there? Heck yeah. Do I hope it's intelligent? Heck yeah. But the number's
let's
1
take-
in a billion?
Let's take the intelligence out.
Okay.
Now, the fact
It's already
is,
out.
let's factor that out. What is the likelihood of just life? I don't care if it's single-celled life. I don't care if it's just, some type of bacteria, amoebas, whatever. What is the likelihood of that happening, seeing as how, the same building blocks that we have here
Are
are
there.
everywhere?
Yeah. Plus, it happened pretty quickly on
And
Earth.
yeah,
Right.
yeah. I mean, we're only 4.5 billion years old, and we got to the life part pretty damn quickly.
I mean, there's planets everywhere, right? Like every star has planets. And so if you think about it, we've got so many planets, so many balls of rock are probably amongst those planets. Chances are good you had the conditions for life, right?
Uh-huh.
And water, some energy. Those things seem like they're out there. So I think the chances are good. But again, 1 in a billion? I don't know if it's that slim.
Yeah, plus we're not even limited to rocky planets anymore because there's some good moons.
There are some great ones.
Right.
That
Nice
habitable
looking moons.
worlds,
Yeah,
right?
yeah,
Not just the habitable
It's
planets.
habitable worlds, not just planets.
There you
right?
go.
World. Forget planet, non-planet. Yeah,
Right.
have world.
World.
There you go.
Okay.
And then I mean, like even like a ice. Well, what would be like an ice world, like Enceladus? So
Yeah, you got that water underneath, right?
Yeah,
Yeah,
but
yeah.
that could happen, right? Like, okay.
Totally have.
All right, here we go. This is Dylan. And Dylan says, greetings, everyone, from Flagstaff, Arizona.
Nice.
I'm taking undergraduate astrophysics courses and learning about spectroscopy. Thank you.
Spectroscopy.
Spectroscopy.
Yes,
I can't.
you
God,
got it.
that always gets me. And other amazing methods of how to find and characterize planets. What has been the best method so far to find planets, and what possible new methods are being thought up?
So let me focus that down and have you tell us we're now using spectroscopy to study the atmospheres
Atmospheres, yeah.
of these planets. So what's coming out of that?
I mean, it's amazing that when you get just the right configuration, that you've got the star and the planet passes in front of it, and you're looking at that, some of the light goes through that atmosphere
Right.
of that planet from the star and gets to us. And so we can actually see some of those chemicals in that atmosphere.
It's amazing.
So we see all
So the
carbon-
chemicals are disrupting really the clean path of light
Exactly.
from the star,
Amazing.
and that disruption shows up in the spectrum.
right? They were like putting their fingers on there, getting those
Get the
finger
fingerprints.
burns.
Yeah.
Right?
So what are you looking for?
So we've seen carbon dioxide with the James Webb Space Telescope, which is pretty
Okay,
cool,
that's
right? The
pretty
first
cool.
time we've seen that on another exoplanet.
All right.
Right? All kinds of other compounds, right? We get water,
Okay.
right?
Sure. Water molecule. Yeah.
Yeah.
Right? And you got some good things in there. And so all kinds of configurations of oxygen and carbon and hydrogen that you're,
One of them.
Think about-
methane.
methane is
CH4,
pretty great,
right.
right?
You get methane there too. Have
There's-
you seen it yet?
There is methane about on the planets, yeah.
Okay.
Okay.
All
That
right.
would be evidence of.
Farts.
It can be. It can be.
All right. Keep going.
That
Check.
is so cool. This is
Oh,
Cesar.
by the way, just to bring closure to that, to say that the boring, obvious fact, so many of these planets were discovered
Exactly.
with just by their spectra.
Right? And by transits, right? That you looked at the light and you saw it blinking, and that's just because
Looked at
something
the light
kept
of the
going
star.
around
Right.
at that light of the star.
And the
Right.
transit is the planet going in front of the star's
Exactly.
light,
Right.
blocking the star's light.
It's just like when we have eclipses where you block out the whole face of the star, but here it's just a fraction of it, right?
It's
So we
amazing.
talk about
Yeah. In fact, solar eclipses are really transits.
Yes.
we talk about the
Yeah.
transits
Because-
of Mercury and Venus,
Yeah,
right?
yeah,
Little
yeah,
black
yeah.
dots.
Mercury transit, Venus transit, it's a moon transit.
That's right.
And an eclipse, technically, astronomically, is just object moving into the shadow of another object.
Okay.
So a total solar eclipse, really, we shouldn't use the term eclipse, but we do.
All right.
Yeah. I thought I'd tell you
Nice. This is Cesar Erno, who says, hello, Dr. Tyson, Dr. Tripathi. Is the James Webb Space Telescope used to look for exoplanets?
Heck yeah.
Okay. So why don't we just zoom in on some
Wait,
exoplanets
see,
and
she
get high
works for
quality?
NASA. She said, heck yes.
Heck yeah.
Heck.
We heard
Heck.
that.
No, let me hear it real. You're in New York City. You're in Manhattan. Say that right.
Yeah. I'm sorry.
I don't think I can beat that. I think you
so
can.
sorry.
Chuck wins
I'm
that.
sorry.
Chuck did
That was just too New York. I couldn't help it.
That's a long bleep on that one. Okay.
No, I think if I had the teacher, instead of I love New York, it would be I love JWST, right? For the
Right.
exoplanets.
Oh yeah.
James Webb Space
So
Telescope.
so I thought it would only be looking closer at exoplanets we've already discovered. Is there a discovery mode?
There are discoveries too, yeah.
How does it do that?
I mean, it actually captures pictures where you see that there's planets in this frame.
Without knowing
Wow.
that in advance.
Yeah.
Oh.
So he said, why don't we just zoom in and get some high quality images?
That's what it's doing.
And that's exactly what
That's
you
what
just
it's
said
doing.
it's doing.
wait. So you see the host star and you see the planet.
You get a hint of the planet being
A
there.
hint of the planet.
We get a little
All right.
dip of tea, right? Dip of planets.
Gotcha.
Mhm.
But the question of can we zoom in on planets there? James Webb is looking at different patches of sky, and if there are planets in there, that's great. But it can't look at just any part of the sky and say zooming in deeper and deeper, because planets don't give off a lot of light. They're just reflecting their starlight, which is so faint that you don't see it most of the time.
Yeah.
Gotcha. All right. This is Gavin Bamber, who says, hello from North Vancouver, where plant life flourishes. And he's not lying. That's a
Northern
Ooh,
Vancouver.
it's so green up there.
Really?
Yeah.
Oh, you can go green blind up there. It's crazy. It's crazy. He says, once we find plant or animal life on other planets, will we be able to eat it? Or
I like
can we
that.
tell if we're able to eat it?
I
Or for
like-
Chuck, will we be able to smoke it?
Well, that's a question for you, Chuck.
Yeah,
Wait, did he say that?
Yes, he did.
No, he didn't.
Yeah, I swear to God. He
No,
said,
he
or
didn't.
for
Yeah,
Chuck,
Yeah,
will we be able to smoke it? But
Okay, so let me ask this. So can we only? I don't know how much biology you know,
Mm-hmm.
but can we process organic matter that has a different DNA from us? Like our DNA is right-handed, like it spirals this way.
Yep.
Like clockwise, looking up.
the double helix.
Yeah, but in principle, you can have DNA doing the other direction.
Right,
But the chemistry shouldn't matter,
right.
all right? Except we don't.
And all those people's skin is on the inside of their body. That's how all their organs are on the outside. They are so messy looking.
So what is the scholarship on just the digestibility of life forms that are not native to Earth?
A researcher doesn't eat and tell, Neil.
A researcher doesn't eat himself.
Yeah. I don't know why that got me.
But I mean, I would say, would you want to though, right? Because I mean, there's so many things that you're like, oh, that cheese doesn't look quite right. I don't know if I want to eat that. Now you're going, I just found this out there. I foraged for some wildlife.
Yeah. That
that
is
looks
funny because
tasty.
a whole lot of stuff on Earth you know not to eat. Now, you that desperate to eat aliens?
Right, I'm just saying, would you want to?
So this is Daniel L. Thompson who says, howdy, Dr. Tyson, Dr. Tripathi, and Sir Nice. And that's Lord Nice. He says...
Lord is above Sir.
Lord, exactly.
Yeah, Lord is totally
why,
above
why
Sir.
would you demote me?
Mhm.
He goes, I'm Daniel from high school in the JROTC, a Junior Air Force Reserve Officer Training Corps. Good for you, buddy.
Nice.
He says, has there been a minimum and maximum size or density to define what would be survivable for humans
I like that.
to live?
I like that.
Yeah, and P.S. Chuck, you're welcome for the easy name. Well, thank you, Daniel. But you can't take credit. I'm gonna thank your parents for that. But anyway, is there? I mean, I suppose planet sizes and the pressure, atmospheric pressure, or gas planets, whatever. All those things would have a.
There was a movie, The Space Between Us, where someone grew up on Mars. An astronaut got pregnant on the night before the launch.
Yeah.
And it takes 9 months to get to Mars.
Right.
And NASA had to hide that information. So she gave birth on Mars and no one knew about it. And then the kid came back to Earth and it was like,
That's pretty cool.
he had a hard time breathing.
Yeah.
And all the things he was used to on
To
Mars,
Mars,
his
he
muscles
can't-
couldn't
yeah,
handle it.
can't
But he was still alive. It didn't kill him. So do you have any thoughts on survivability of low or high gravity?
I mean, I'm a big fan of Earth, right? So like looking for planets like
Right.
Earth because, I like being able to jump up and down rather than Jupiter. I don't know, jump up. Where are you going next, right? All right.
Right.
And, having that nice solid surface. So, something sort of the size of Earth is nice and cozy. And we seem to do okay.
Oh, wait, so your point is if it's much more massive than Earth, it's not a rocky planet. It's gaseous.
You're getting
Because
gases.
it kept all of its gas.
Right, yeah.
Okay, so that's out. The upper end of that's out.
Upper ends out.
Okay.
I don't know how low we can go, right? Because we've got moons
Mhm.
that are possibly good places to live, right?
Well, our moon is 1/6 gravity.
Right.
Right. So that's not going to kill you.
It's not going to kill you. You're going to get some
But
help,
you don't want
right?
to get used to it and
I
then
was
come
gonna
back
say,
to Earth.
yeah, I mean, 3 generations later, you have the bone density of a marshmallow.
But you've got the space suit, right? That, it's a souvenir, right? All I got was this lousy space suit, right? When I came. You're not going to be buying for my souvenir shop anytime
No.
soon, are you? All right, I understand. It's okay. So, I mean, I think, down on the lower end, it's hard to say how low you can go. It is interesting, though, that when we look out at exoplanets, we find some where there are these little planets that actually end up just getting evaporated away. So instead of their atmospheres being all that evaporates, you got just like crumbly planet going off into
wow.
space,
Wow.
right? So you got the wrong conditions there. So it's not just the size of the planet, it's how close it is to the star and
Right.
everything else it's feeling. So
It probably feels tidal forces that'll disrupt
If you
it
get the right-
structurally,
Right.
too.
yeah.
Okay,
so
but when they say super Earths, we've heard this.
that's right.
Yeah,
Bigger than
among
Earth.
exoplanets.
And nothing we
Super,
got.
how big is super?
Bigger than Earth, right? Smaller than Neptune, right? So you think like, that's in between.
So you might
Super.
be twice your
Twice.
gravity?
Right.
Something like that?
Could
About
do,
10
right? We
times.
talk about it in terms of the radius of it.
Oh,
So
right.
how's the size of it? Because the super Earth, right, it could have a surface. It could be a little bit more puffy.
Okay, but so how big a radius compared to Earth if it's a super Earth?
Depends on your definition, right? It's a few times.
A few times, yeah.
Yeah.
Okay, a few times, but that's pretty
Okay.
big.
That's pretty
No,
big,
no,
right?
so normally when people
Yeah.
think of, it's twice the size, but if you can range 10 and 100 times bigger,
Yeah,
a factor of 2 is just friendly.
yeah,
You know?
exactly.
I mean, we have a poster that we made of people skydiving on a super Earth because they thought, oh, that'd be fun, right?
Yeah.
You'd be falling faster.
I personally don't think
A
it
lot
would be
faster.
fun.
Yes.
But our art team thinks it's great.
Yeah,
and
no,
I, I think that's great.
Yeah.
But, there was also the question in there of the density, right? And I definitely want to be on that ball of rock rather than that ball of gas like Jupiter
Definitely.
because I like having a surface.
You like want to land somewhere. Okay.
Yeah.
And so, but what if, like, when we retrieved, part of the asteroid,
Mhm.
right? We were able to do so because we put the drill down in a place where we knew it was crumbly rock. So what if we know that it's a super Earth, but it's kind of made of that composition of crumbly rock?
I mean, I would love to get to that point, right? Right now, I'm just like, it weighs this much. It seems this big. Divide some numbers.
I don't
right?
think that's a real thing.
Really?
Yeah, because if it's big enough and has a strong enough gravity,
Right.
it'll
It'll
compactify.
right. It will
Right.
condense.
The problem with the asteroids, they don't have much gravity.
Right.
Right.
So,
and that's
so
right.
they're like loosely,
Absolutely.
they're loose. Plus, it didn't drill. It was a touch and go.
It was right. It was bang,
It went
and then it sucked up what was
grabbed whatever
came
popped
up
in
inside of it. Yes,
right, and they were ready for just a couple ounces.
Yeah.
They got half a pound.
Right,
A pound, so they were good.
But no, you're right. The gravity makes that makes sense.
I mean, you got to be a planet, right? You got to be a
I
planet.
live to have you say.
You try that. You try that. I was just like, you know what, Neil, you're right.
All right, we got time for like one and a half more questions. All right.
One more. All right. Okay, let's go with Andrew Nisker. And Andrew says, hello from Flesherton, Ontario. Can you please explain the different types of biomarker gases? How will the next generation of telescopes enhance our ability to study exoplanets? Guess that's two separate questions, but hey, I'm always looking up, so I have to ask lots of questions.
Nice. So picking up on the earlier question,
Yeah.
you mentioned water molecule, methane,
Yeah.
and carbon dioxide.
Right.
But is there like the greatest hits of what would reveal life on the surface?
I mean, there's so many different ways that we can search for exoplanets with life, right? Those signatures, right? We call them biosignatures or technosignatures if you even want to go a little further afield. And so the fact that, you could look for pollution on a planet,
That'd
right?
be a technosignature.
Well, depending on how you count it,
Okay,
yeah.
all right.
Right, but I mean, like you look for chlorofluorocarbons, right? From your, hairspray on your alien world.
Okay.
That would be a slam dunk for life, even though it's not one of the things we've historically always studied,
Right.
right?
Right.
These sorts of things. And so, signatures like methane,
Wait, so if the chlorofluorocarbons, they're idiots.
but they're idiots we can see, right?
No sign of intelligent life there. But
Exactly.
they're getting rid of their ozone layer.
Which is probably what they're saying about us when they actually see the biomarkers from this planet or the technomarkers from this planet. They're like,
Right, I mean, it's like, if you were really smart, would you want people to see you and find you?
Right.
Whole
So
separate
any more?
question.
What's it? Phosphate was one of them?
So phosphine is something that
phosphine.
people have talked about
Excuse me.
possibly, no, it's all good, it's all good. Being detected possibly in Venus, and whether that's a sign of life or something else, it's probably something else there. But I think there are lots of detections of all of these more complicated molecules, right, where you start putting things together.
That would be there only if you had life on the surface.
That could be caused by life, right?
Okay.
Like the chlorofluorocarbons would only be caused by life, but methane could be common from something else.
Okay, because you can get naturally occurring methane.
Right,
Okay,
yeah.
so what about oxygen?
Oxygen could be there. It can be, I mean, when you look at,
I don't know how you get oxygen unless somebody's making it, like with plants.
I mean, like, look at the history of the Earth, right? For billions of years, we've existed, and we didn't have this much oxygen that whole time, right? Like, go back in time. So you not only need to look at that planet and just see what it is, but at this particular moment in time.
Because when I saw the original Star Trek, do you remember that in the original Star Trek, no one ever wore a spacesuit?
No.
When they went down on
They didn't
planet.
wear a spacesuit. They never wore a mask.
Right.
Or anything.
You know why? Because they would establish oxygen, nitrogen, atmosphere, Captain.
Yep.
Well, let's go on down.
It's a Class M planet.
Right, exactly.
With breathable atmosphere.
So I'm thinking, if you just look hard enough, you find other oxygen, nitrogen planets. And then I realized later that you're only getting the oxygen from living matter on the planet. It's not just some random mixture in the random assortment of planets. Somebody's making the oxygen. And on Earth, it's our plant life.
But I mean, we can also, when you form a planet, you got all kinds of chemistry going on in there and things going into the rocks. And so what goes on in your atmosphere, some of that just happens naturally.
Okay. So you're going to have to distinguish those cases. And so getting the list is one thing, and then you fight about whether it's biological or not.
Exactly.
Yeah, at the conferences. Yeah, that's good.
That was a good question.
Chuck, time for one half a question.
Oh my God. Let's see. Let's go with Captain James Riley, who says, hello, everyone. Texas here. Is there a most common atmospheric composition out there among rocky planets?
I like that. That's related to that last question.
Related to the last question.
I love that question. And I think in the last question, he asked about the telescopes. And I think the answer is we need more data, right, to answer this because we haven't been able to tell the atmosphere.
I'm not allowing you to cop out and just say we need more data.
No,
talk to me. Give me.
But I mean, I think that's the thing is that so many of these things, because if it's a cloudy day, you can't see what's going on underneath, right? You see clouds, you see like water vapor up there, right? So there's so many of these systems where you think like, hey, I need this new telescope.
Okay, so of all the planets where we know anything about their atmosphere, is there an emergent common list?
I think it's kind of like the zoo, right? There's some common things, like there's all those things with tails, so there's all those things with oxygen, there's all those things with carbon and methane, right? It's the sort of thing that we haven't seen enough to be able to say this is the most common thing yet. So not yet.
So like the zoo, you have animals with tails, animals with 4 legs,
things with wings, right? Like it's just
okay.
you
So
can
there's
start
the blunt,
classifying them.
The blunt, you start blunt.
Right.
I think what it means is we got to chat more again in a few years, and then we can do better.
Oh, that means you'll come back.
Come back.
Well, very cool.
Yeah.
By the way, I understand you have a TED Talk?
I do.
Yeah, on
atmospheric escape.
Whoa.
Oh, okay.
Okay. Well, I'm not watching that.
But
I'm scared to death.
you know that how it ends.
Well,
you know you're
that's true. I
safe,
do
right? You know how it ends.
I'll
So
die
no
long
problem.
before. Yeah, I'm
So
good.
you're the first to model the escape of gas from atmospheres.
Doing that in 3D for these planets.
3D modeling.
Yeah.
So
Oh, cool.
in the old days, computers weren't fast and we didn't
Yeah.
have AI. And so you do like 1D modeling and 2D modeling just to approximate the 3D modeling because you couldn't calculate it. And then when computers get fast enough, then she comes along, says, I got this 3D,
Boom.
all in.
There you go.
And it's hard because you're modeling gas.
Right? You're just watching it flow.
Yeah. The flow of gas in a computer model, that's not easy.
It's not let it go, it's let it flow, right?
Right. Okay. But I mean, what's funny is like, isn't that like gas is, what's that? As gas moves towards entropy, it's just chaos, right? So what do you?
Somewhere in between, right? Because it was starting on the planet in the atmosphere and just blowing off into space.
Okay, so that's what you're doing. You're going from where it's
Pure
very more
coming out.
stable and then
Right.
to its instability.
There you go.
Okay.
Yeah.
All right, we're good. Chuck is good till the next time.
I'm feeling better.
We feel a little
That's
better.
good, that's
I'm feeling
good.
better. Yeah.
I mean, you got to be feeling totally better. Right?
So, Anjali, thanks for coming on to StarTalk.
Thanks for having me.
We'll continue to follow your career.
Appreciate that.
There's still a few more presidents you can
Yeah,
work for.
exactly.
Don't slouch.
Work on it.
You got to get back in the White House. So that
Yeah.
I mean, I'm the exoplanet ambassador though right now, right? So got to go visit those exoplanets too eventually.
You have an ambassador title.
Oh yeah, no, I'm NASA's exoplanet ambassador.
Oh, sweet.
Oh my God.
That's very cool.
So do you speak at the UN?
I speak for the State Department.
The Galactic UN.
Oh, yeah, there
That's
you
where
go.
You get to speak. That's
So when the aliens come, when
Right
they say,
here.
take me to our leader, I'll say, well, we have an ambassador.
We have an ambassador. Is that good enough?
Yeah.
Something like that. Yeah.
No, we say, we ain't taking you to our leader.
Yeah.
You're the ambassador is going to be what you're going to meet here.
But believe me, yes, it will be a scientist or Taylor Swift.
The doctor will see you now.
All right. Well, good luck in your continued
Thank you so much.
career and your ambassadorship. And we'll want a full update
All right, sounds good.
as more exoplanets show up and more aliens visit.
Okay.
You'll be first on the list.
All right.
Nice.
Thanks.
All right. Good. This has been StarTalk. Neil deGrasse Tyson here, your personal astrophysics. Chuck, thanks for
Always a
being
pleasure.
there. All right. And as always, I bid you keep looking up.